everyone. I'm Aditi Kinkhabala from New LJ Institute of Engineering and Technology. Let us start with the next topic of Q, which is circular Q. Before that, we will also see what are the drawbacks of linear Q. Now, students, in the last lecture, we saw what is a linear queue. So it is basically a data structure which follows first in, first out order, right? So there are two pointers in queue, which is rear and front. So insertions, if we want to add element inside the queue, we can add it. That is, we can enter the element, insert it using rear pointer. And once we enter the element, so we increase the pointer, rear pointer, and we add the element. Similarly, in queue, deletions are always done from the another end, and that is called front. So considering this representation of queue in form of an array, so this array has 10 elements, 0 to 9 is the index. So currently this array, that is Q, is completely full. So the front is over here, right, at the pointing at the first element, and it is at 0, and rear is at the last element, which is at 9. So currently, as per the current scenario of Q, we cannot insert any new element because now rear would be greater than equal to the total size n, right? So insertion is not possible because the Q is completely full and there is no empty space where the values can be inserted. Now, what happens in this scenario? That is when there are two successive deletions. So when we delete it, what will happen? This element is deleted and front is incremented. Again, this element is deleted and front is incremented. So now, after two successive deletions, front will be pointing at the second index and rear is pointing at the 9th index. Now, there are two empty spaces left. But now also, if we want to insert a new element in the queue, it will still show r greater than equal to n, and that is queue overflow, right? So even though there is space available, the overflow condition still exists because this condition, that is max minus 1, or we can say r greater than equal to n, still holds true. Now, this is the major drawback of linear queue, because even though we have spaces, once it is rear pointer has shifted, we cannot insert new elements. Once the elements gets deleted, we cannot insert new element at that particular location. So this is the drawback of linear queue, and which is overcome by other forms of queue that we are going to see in coming lectures, right? So the first form is circular queue, which solves this drawback of linear queue. There are multiple types of queue, right? So queue data structure, we can have linear queue, which we just saw. Then we have circular queue, we have double-ended queue, priority queue, and so on. So let us see the first one, which is circular queue. Now, students, in circular queue, so this is one kind of visualization that circular queue, basically, in circular queue, first index comes right after the last index. So if you can see here, queue starts from 1, 2, 3, 4, 5, and it goes till queue of n. Right now, front pointers. So for example, if this queue is getting filled, after the rear reaches the last element, the next element is basically again pointing towards the first one, right? So we can say that in circular queue, this circular queue will be full only when front is 0 and rear is max minus 1, that is greater than equal to n, right? So when front is still pointing at 0, that means if this is front currently, if this is front and this is rear, okay, so after inserting element, for example 1, 2, 3, right? So if the last element is rear, right, so if last element, so it would be rear will be pointing towards the last element, and front, none of them is deleted, so front will be pointing on the first element. So when we say that front is 0, right? So if it is in form of array indexing starts from 0. So if front is 0, and in case front is 0, if it starts from 0, what is the last element? Whatever is the maximum size. So max, we can say max minus 1, or we can say n minus 1, right? So this is the scenario where circular queue is completely filled, right? Now a circular queue is implemented in the same way as linear queue, okay? But the only difference we will see will be in the code that performs insertion and deletion. Because in linear queue, we just saw that what is the drawback, that it cannot come back over here, right, at the first position. Linear queue was not able to do that, right? But circular queue would be implemented in such a way that if we increment rear from the last position, it will come to the first position. So this is how we are going to implement this circular queue, right? So now let us see, it is basically one kind of array only. So let us see a tracing of circular queue. So here the first thing is circular queue is empty, and currently f and r at this location, it is pointing. For example, if it's 0, so f and r are 0 and this is empty. Now if we insert a, so what will happen, students? A will be inserted, rear will be incremented, and on the first entry, front will also be incremented. Insert B, now rear is incrementing, insert C, again rear incremented, C is inserted, and insert D. Okay, so at this particular position, we can say that this circular queue is full. Why? Because this circular queue is full. Why? Because front is at 1 and rear is at n. Okay, so now this circular queue is full. Now let us try to delete one element. So if we delete A, what will happen? A will get deleted and front will be incremented. Okay, and now if we want to insert E, this is possible via circular queue. This was not possible in linked list, but in circular queue, it is possible that this E will be inserted, that is this pointer would be incremented and it would be again pointing towards the first location. So you must visualize this, that it is in a circular way, right? This is a circle and we have B, C, D, right? Okay, so there A was here, so we deleted A, so this space is blank. Currently rear is over here, and now if we try to insert E, rear pointer will increment and come over here, and then it enters E, right? So this insertion is possible in circular queue, right? So this rear pointer has now come in front. Now delete B. So B is deleted, front pointer is incremented. Insert F. So again, F can be inserted. Next, delete C, front pointer incremented, and delete D. So again, front pointer now points towards the first element. Okay, delete E. Now E and F are now front and rear are at the same location. And lastly, if we delete F, what will happen? This element, first of all, it will check that F is equal to R. So in that case, we need, that is the case for empty queue, right? And in that case, we have to set F and R back to 0, and then the element is deleted. Now let us see the operations on circular queue. So circular queue insert, and then we have circular queue delete. So what is the algorithm for circular queue insert? We require 5 things. We require Q in order to insert element. F and R are front and rear pointers. N is the size of the queue, and Y is the element we need to insert, right? So F and R are initially set to 0. So F and R both are initially set to 0. Now we need to see, students, do we need to reset rear pointer? Right now, this is in situation where we have space, but currently rear pointer is at the end. So this is the situation similar to this. So here it is BCD, right? So here we have front and we have rear, right? So do we need to reset rear pointer? So this is, we have to reset rear pointer if it is showing at n. So the size is n. And now if this is 1, 2, 3, 4 and n is equal to 4, so yes, r is equal to n because r is 4 and n is also 4. In that situation, what we will do, we will initialize r to 1. So r will be initialized to 1. Okay, so it will come back to the first location. In which scenario? When r is equal to n. In any other scenario, if the scenario is this, right? So 50 and 60 and r is over here, front is over here. So in this scenario, r is not equal to n. So we will go in else part, which is r plus 1. So here we will take our pointer, that is r plus 1. So in the first step, we will reset the pointer. So the next condition is overflow. So after resetting the rear pointer, right? So if we reset pointer and it comes to 1, and when it comes to 1, right? If it is over here and if we reset it, but what if this condition is like this q is full and rear is here, right? So we can say that r is equal to n. And so we will place r is equal to 1. But here we have front and now rear also will come over here. In this situation, f would be equal to r. So this is the one situation where it would be still overflow because none of them is getting deleted, right? And in other situation, when we have r is equal to r plus 1, right? So in that scenario, overflow will not occur. If front and rear are at different points, so overflow will not occur. Otherwise, if f is equal to r, we can say it has overflow condition. Now, if we don't have overflow condition, then at q of r, we need to give the value y, right? So again, if this is the condition, that's 60, this is r, this is f, and now we are incrementing r, so r will point over here. So if this is indexing, what is q of r? Q of r is q of 3, and at that we will place y with whatever value. For example, if y is 5, this will be placed over here, right? And the last step is to check, is the front pointer properly set? Now students, the front pointer setting we need to check for this scenario. For example, this q is initially empty, 1, 2, 3 and 4. Front pointer and rear pointer, front and rear are both 0. We are inserting one element. So what will happen? Rear will be here and we are inserting, for example, 30. Now in this scenario, when the queue is empty and we are inserting first element and the first element is inserted, what does it mean? That element can get deleted also. But if we try to delete, front is currently 0. We have not set the front pointer. So as soon as the first element is filled, we need to also set the front pointer properly. So in that scenario, see, we just inserted one element. That means if one element is inserted, it could get deleted, right? It could get deleted. So if front is equal to 0, even after insertion, that is a wrong thing. And that's why we need to change it to 1. So we will also set the front pointer to 1. So if it is not set, we need to set this front pointer to 1. Now let us see the operation on circular queue, which is circular queue delete. And here we do not require any y. Y would be definitely needed, but it is a temporary variable. Okay, so the algorithm name is CQ delete. Front, rear pointers are needed, Q and the size. First of all, we need to check for underflow condition. So if front is at 0, definitely it would be an underflow condition, that is circular queue is empty and we cannot delete any element. What happens if it is not empty? In that scenario, whatever is there at q of f, for example, consider this diagram only. So q of f, that is q of 1, that we will place, whatever is there, that we will place in y. So a will be placed in y. So we will return y later on. So currently that a is placed on y. Okay, so a is placed on y. And now we need to check after deleting, is q has gotten empty, right? So if did the q get empty? So if condition is like this, f is equal to r, on deleting, see, for example, this could be the situation. that we have this 30 here, we have rear pointer 40, and here we have f, right? So we are deleting 30, so 30 would be deleting. We will check that if f is equal to r. No, currently f is not equal to r, so we are returning it, right? We are incrementing the first pointer, so we are incrementing, it will go over here. Now currently f and r are same, right? So we front pointer, so we will give this 40 to y, and if you see, f is equal to r, clearly it is seen that f is equal to r, and we have already placed 40 in y. So now the q is empty, and we need to set this f and r pointer again back to 0, and we return y. Okay, so y consists of the element, value of the element which is to be deleted. Right now, what if the scenario is that the front pointer, so q is not empty? In that scenario, if the q is not empty, we also need to check whether f is over here front. In that scenario, what will happen, students? All these elements are empty. We have 30 over here currently. Okay, so we have 30 over here. 30 is already going. So if we have some element 40 over here, rear would be pointing over here. So y, this is y, it has value 30. Now we can say f is equal to n. Yes, it is the last element, so now it has to be 1. So if f is equal to n, it will come back to 1, and if it is not equal to n, so it could be any other position. At that time we just have to increment and return the value of y. So q empty, only at certain times only we will enter this q empty situation. Other time we will come across this incremental situation. So this is how we perform circular queue insertion and deletion. Thank you.